Hey friends, Mr. Warden out here in the workshop. It is a beautiful evening here in this neighborhood and we're in a good mood today, which means we're gonna make a few videos. Okay. As most of you guys know at this point, I am currently restoring a 1991 Chevy G20 van, and I recently purchased this. I'd like to show you this. This is a wiring diagram manual for that car. And what this is a series of schematics about how the car is wired, about all of the electrical connections that make up the car. Okay. I think that's pretty neat. And so I wanted to take this opportunity to talk about electrical systems, to talk about circuits, to talk about cars, to talk about batteries. And so that's what we're going to do right now. How do batteries work? It's a good question. I have my normal Amazon D battery that I've been using as a demonstration piece for a while. How do batteries work? It's a good question. Batteries like this, actually most batteries, work chemically. You've most likely heard people talk about battery acid before. And why is that important? Well, inside here, there is battery acid. That stuff that, when a battery goes bad, that stuff that leaks out and is different colors. It's usually some kind of blue or green or white. That's usually some kind of sulfur compound, sulfite. There's battery acid in here. And as that battery acid reacts with kinds of metals in here, it produces an abundance of excess electrons. Okay. And so there's an abundance of excess electrons in here from that chemical reaction that's taking place. Whenever we connect a copper wire, a conductive piece, to the negative end of the battery, where the electrons are, they'll leave. They'll exit the battery, because it's just like the LED we were talking about. There's lots of electrons that are trying to go this way. They're being pushed this way. They're like, come on, let's get out of here. And so as soon as you put something that's conductive on the battery, it's going to go. It's going to leave. The electrons are going to want to leave the battery, and so they do. And that's pretty cool. That can allow us to do lots of different things, like run LEDs, for example, or run light bulbs, or run speakers, or buzzers, or horns, or cars, for example. So let's take this and take a look at one of these wiring diagrams, and I'll show you with a problem that I'm working with right now. So a car battery has a very strong battery acid in it, okay? Some kind of sulfuric acid, again, some kind of sulfur compound, right? And it produces lots of electrons because it's got a lot of places to go. It's got a lot of things to do. The problem that I'm currently dealing with is that I'm having a hard time figuring out what the person who owned this car before me did and why. Because I opened the hood up of this car and there is just wires everywhere. Things are going in weird places. Nothing really makes any sense. And so I bought this in order to try to figure out, okay, if I'm going to have to put all this back together, I want to make sure I do it right. And I want to make sure I do it the right way. So this is the first actual diagram page that we come across. The rest of that is sort of reference about how circuits work. If you can look here, I'm trying to find a pointer or something. There is a battery up there in the top left of the screen. Car battery. It's got a positive side and a negative side. There's a chemical reaction happening inside, and that is producing excess electrons that are ready to go. And the electrons go. So electrons are going to travel from the negative side of the battery into the connector, and then there's this dark black line, and that black line represents two different wires. Okay. And these two wires go this way, and the electricity travels this way through these two wires, past all this nonsense. Don't worry about that. We'll come back to that. Past these two wires into these two things, into these two grounds. Okay, what are the grounds? Well, ground is literally the ground. It's literally the earth. But in common situations, the ground is simply a large reservoir of extra electrons. Okay. Imagine a well of infinite electrons. That's what the earth is. Okay. That's what ground is. However, most large metal objects can stand in for ground. For example, on a car, the sheet metal which surrounds the car is a ground. Likewise, the engine is a ground. And everything on the car is grounded to one of these two things. And so what we're doing with this connection right here is we are sending electrons into the engine and into the sheet metal so that we can then send them to every other place they need to go, like the headlights or the radio or whatever, anything. And so this is the first thing that we would need to check. We need to make sure that there's a connection going from the negative end of the battery to the sheet metal, and then from the negative end of the battery to the engine. Now, my thought was, thinking right now, my understanding is that I've done that. But when I did that, the sheet metal ground wire melted. And that's a problem. You can imagine my dismay whenever I go to turn the car on and smoke starts coming out of the hood because the ground wire that I connected melted and basically vaporized. That was a bit harrowing. So why did that happen? I don't really know. But one of the reasons that can happen is because there was simply too much electrons. There's too much current going through that wire, and it was not equipped to handle it. Too much energy. And it got really hot. So it vaporized. We talked before in the LEDs video about how incandescent light bulbs used to work and how they used to glow because electrons were flowing through this very thin wire. It was like that, except it didn't glow. It melted, and that was a problem. So I guess what we're going to do is we're going to have to figure out what kind of gauge of wire this is supposed to be. Because I have lots of different kinds of wire, but the wire that I used, evidently, it melted. So let's look in the book and see if we can figure that out. Okay, as you can see here, there's a little label going from the inside the wire, and it says 1-32.0 black. Okay, now, luckily on page 8, there's a table. And I think perhaps that means 32 millimeters, which would be equivalent to 2-gauge wire. Wires come in different sizes, different thicknesses, different diameters. And I believe that's what I did. I'll have to double check that. However, the second wire says 2-3.0 black. What does that mean? Does that mean 3 or 2 or 3 wire gauge? Does that mean 2 different wires going to sheet metal ground? I don't know. Let's do some more research. All right, this guide on page 4 tells us that all wire gauges are listed in millimeters. So let's go back and find our diagram again. This is circuit number 2, 3.0. So a 3.0 wire is 12 gauge. Okay, so we have some 12 gauge wire. Let's take a look in the electronics stack over here. There's some wire. What gauge is this? Just for the sake of reference. Unknown. Could be anything. Well, we'll find some. All right, for the sake of reference, this is 10 gauge wire. So a 12 gauge wire would actually be a little bit thinner than this, but you get the idea. I believe that the wire I did use that melted was in fact much smaller than this, and quite too small. So let's get some 12 gauge wire to see if we can fix that. Now the color of wire, it says black, and black is traditional for ground. Ultimately not required, I guess. The color is just a protective sheathing on the outside of the wire. So we'll see if we can get some black. In the meantime, live the curious life, friends.